Good morning. I am Mrs. A. Arokiamary, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. Now we are going to see how to form partial differential equations. First, let us see what is partial differential equation. A partial differential equation is an equation which contains one or more partial derivatives. The order of the partial differential equation is that of the derivative of highest order in the equation. Let z equal to f of xy, where x and y are independent variables and z is the dependent variable on x and y. Then dou z by dou x, dou z by dou y are the first order partial derivatives. Dou square z by dou x square, dou square z by dou y square, dou square z by dou x dou y are the second order partial derivatives. Now for example, the equation x square dou z by dou x plus y square dou z by dou y equal to z square is called the first order partial differential equation. The equation x square dou square z by dou x square plus dou square z by dou y square plus xy dou square z by dou x dou y equal to 0 is called the second order partial differential equation. For convenience, we use the following conventional notations for partial derivatives. Dou z by dou x is p and dou z by dou y is q, dou square z by dou x square is r, dou square z by dou y square is t, and dou square z by dou x dou y is s. Then these two equations, equation 1 and 2, can be written as x square p plus y square q equal to z square and x square r plus t plus xy s equal to 0. In ordinary differential equation, we have seen that the differential equations are formed by eliminating arbitrary constants. In the same way, partial differential equations are also formed by eliminating the arbitrary constants from a given relation between the variables. Also, partial differential equations may be formed by the elimination of arbitrary function of the variables. Hence, partial differential equations may be formed by eliminating arbitrary constants. The second one is by eliminating arbitrary functions. Let us see some examples. Formation of partial differential equations by eliminating arbitrary constants. Consider z to be a dependent variable and x and y to be independent variables. Let the relationship between z, x1 and y be defined by f of x, y, z a, b equal to 0. Here the arbitrary constants are a and b. To eliminate these arbitrary constants a and b, we differentiate one with respect to x and y. Differentiating with respect to x, dou f by dou x plus dou f by dou z and dou z by dou x equal to 0. That is dou f by dou x plus p into dou f by dou z is 0. And similarly, dou f by dou y plus dou f by dou z and dou z by dou y equal to 0. That is dou f by dou y plus q into dou f by dou z equal to 0. We can eliminate the arbitrary constants from 1, 2 and 3 and get phi of x, y, z, p, q equal to 0, which is partial differential equation. Now, it may be noted that if the number of constants to be eliminated is equal to number of independent variables, then the equation will result in first order partial differential equation. If the number of arbitrary constants is more than the number of independent variables, then second order partial differential equation will be formed by eliminating arbitrary constants. Let us see example. Form the partial differential equation by eliminating the arbitrary constants from z equal to x square plus a into y square plus b. Here a and b are arbitrary constants. Z equal to x square plus a into y square plus b. Differentiating partially with respect to x and y, we get dou z by dou x. P equal to, when we differentiate this, 2x y square plus b is constant. And similarly q equal to 2y into x square plus a. Now multiplying this 1 and 2 will get pq equal to 2x into 2y, 4xy into x square plus a into y square plus b. Or we can say pq equal to 4xy, this is z. X square plus a into y square plus b is z. So 4xy is z. This is the required partial differential equation. Let us see one more example. The equation of any sphere of radius r having its center in xy plane is given by x minus a whole square plus y minus b whole square plus z square equal to r square, where a and b are arbitrary constants. Now we are going to form partial differential equation by eliminating a and b. X minus a whole square plus y minus b whole square plus z square equal to r square. Now differentiating partially with respect to x and y, we get 2 into x minus a plus 2zp equal to 0 and 2 into y minus b plus 2zq equal to 0. Or we can say x minus a equal to minus zp and y minus b equal to minus zq. Now squaring this will get x minus a whole square is z square p square. Similarly squaring 5 we will get y minus b whole square is z square q square. So adding these two will get z square into p square plus q square plus this z square equal to r square. That is z square into p square plus q square plus 1 equal to r square. This is the required partial differential equation. Now let us form the partial differential equation by eliminating arbitrary functions. Form the partial differential equation by eliminating arbitrary functions from the equation. Is it equal to f of x square plus y square plus z square? Now this is the equation. So differentiating partially with respect to x and y, p equal to f dash plus differentiating this 2x plus 2zp. And similarly q equal to f dash into 2y plus 2zq, or dividing p by q equal to x plus zp by y plus zq. Cross multiplying will get p into y plus zq equal to q into x plus zp. Now py plus pq is that, here also we get right side pq is that, those two will get cancelled. And so we get py equal to qx. This is the required partial differential equation. To see one more example, form the differential equation by eliminating the arbitrary function is that equal to y f of x plus x into g of y. Differentiate partially with respect to x and y, we'll get p equal to y f dash plus g of y and q equal to f of x plus x g dash of y. And s dou square z by dou x dou y will get f dash of x plus g dash of y. Now multiplying this by x, xp equal to xy f dash plus xg of y. Yq is y f of x plus xy g dash. Now xp plus yq is xy f dash plus xy g dash plus xg plus yf. That is xy into, this is s, f dash plus g dash. So xys plus xg plus yf is z. So this is the required partial differential equation. Now by having two functions, eliminating two functions. Now this equation can be written as f of x plus y plus z comma xy plus z square. This is of the form f of uv equal to 0, where u is x plus y plus z and v is xy plus z square. Now differentiating this partially with respect to x and y, will get dou f by dou u into 1 plus p and dou f by dou v into y plus 2zp equal to 0. And similarly, with respect to y, when we differentiate, we will get dou f by dou u into 1 plus q plus dou f by dou v into x plus 2zq. Eliminating dou f by dou u and dou f by dou v from these two equations, 1 plus p, 1 plus q, y plus 2zp, x plus 2zq. The determinant value is 0. Finding the determinant, 1 plus p into x plus 2zq minus 1 plus q into y plus 2zp equal to 0. Simplifying, we get x plus 2zq plus xp plus 2zpq minus y minus 2zp minus qy minus 2zpq equal to 0. 2zpq gets cancelled and we get p into x minus 2z minus q into y minus 2z equal to y minus x. This is the required partial differential equation. Thank you.